pencils. If you don't have a pencil, there's a blue box of pencils. You can take one and, because of COVID, just keep it. But I mean, if you put it back, I won't know. All right, let's start. I guess we should stream it. Start streaming. Okay. Start recording. Cool. All right. Let's talk about how we pass information. Does that sound like a good plan? Calm down, people. Good? All right. Let's pass some information. So, suppose I have a piece of string. And then suppose that I get 2 plastic cups and I tie the bottoms of the plastic cups to the string and I pull it tight. What did I just make? A telephone. Have you all done that before? Yeah? When we talk about when you pull the telephone, the wire tight, you can talk through it and what happens? Okay? And then you can hear it on the other end. Yes? Is this anything new to y'all? No. Alright, here we go. So, we're actually going to draw little vibrations because that sounds like fun. I like art. So, when someone talks really loud, there's lots of vibrations. Right? And then you got that annoying thing when they just like breathe into it and there's just little bitty vibrations. But if you're talking to somebody, almost all the time there will be some vibrations because there's a living person on the other end and they just can't help themselves but send some vibration. Yes? Like they're going to send some sound. Okay? So, and then they breathe and then they might talk for a long time and then they're breathing and then they talk and then they breathe and it varies. Now, suppose, yuck, no, there we go. Now suppose we wanted to do the same thing but this time we wanted to do it with electricity. How would I do that? Sure, what does that mean? See, you just use like big fancy words and think you get out free. Okay, so I could send, let's see if I can get this right. I could send a big old chunk of electricity. No. I could send a big old chunk of electricity, right? Zap. Or I could send what? A small amount. Did y'all ever play that game in, Did y'all ever play that game in elementary school where you like whisper something to the person next to you? Telephone, right? You like whisper. We can't do it COVID time. It's just a terrible idea. But pre-COVID, you could whisper a message to somebody, and then they whisper to the next person. Imagine if you were doing a similar activity, but you all stood in a circle, and everybody held hands, and you could pass like a squeeze message, right? Like 1, 2, 3, 1, 2. Yeah, and you could pass it to the next person. Yes? Yeah. And you could have like a break your hand squeeze and like a light squeeze if you wanted to. Yes? Does that make sense? And we do the same thing with electrical pulse. Just send a lot of charge or a little bit of charge. A lot, little, little. And you could just change it. And the way that the charges are organized can communicate either a high value or a low value. Good? So, let's do another high. And we can do, no! I'm trying to color code these. It's not working out very well. Go low. Go low. Go low. Now, how do I know this is 3 lows? How would I recognize 3 lows in the system? No, I ain't positive. There's no color. The color is just to represent highs and lows for you. How do I know that it's low? How do I know that's 3 lows? They're not separated. There's a beat. Right? And if all of a sudden I go, right? If it's a higher one, if it's the same timing, then you just go, oh, that was a low, that was a low, that was a low, high, low, low, right? Because of how long it took. And you just know to expect the beat. So, here, I would need a device that could send a lot of energy or a little energy at regular intervals. Yeah? So if I want to send it, should I put a little like arrows? They're similar. Send that, right? Then, for sending, I would have a device that could send it. And on the receiving end, what do I need? So I need a device that can tell the difference in high and low energy and save it, because I want to be able to hold that information. Yes? Y'all following that? Yeah? Okay. So, let's take a look. Let's take a look at this device. Yikes. Let's take a look at this little device here. So, I'll go 1, 2, how many are there? 8, 3, 4, 5. Yeah, copy paste into the wind. So, can you imagine if I had a bank of these and I had wires connected so that it would just start pumping them in one at a time? That would work, right? You all follow me? Yeah? So I would come in and I would go, okay, that's a high, yikes. That's a high. That's a low. That's a high. There are 3 lows. Oh, okay, we'll hit 9 there. That's a high. That's a low. You all following me so far? And so I just took the message that I got and I turned it into information. And then we could say that anything that was a high would be like a 1. And anything that was a low would be like a 0. And the reason that we don't do more than that, which we totally could, but it would take up more space and it would be so much harder to develop that technology. And so we've learned just high-low. Easy peasy. Right? And so now I'm holding 1s, 0s, 1, nope, not 2, 1, 0. And each one of these is called a bit. So in the technology world, when you hear about a bit, it's just a single 1 or 0 piece of information. But what you probably don't know if I were to guess. Is it a collection of 8? What do you call a collection of 8 bits? Put your mask on. What do you call a collection of 8 bits? One byte. So when we talk about a megabyte or a kilobyte is 1,000 of these. A megabyte is 1,000,000 of these. A gigabyte is 1,000,000,000. Or 1,000,000,000. 1,000,000 sets of 1,000. So, but 1 byte is just 8 bits. Cool, yes? All right. So let's figure out how we're going to work with this to save information. Why are you not connected? Well, let's go. Get out some paper. So we can only count with 0 and 1. And we're going to like build this up from round 1. So if I can only count with 0s and 1s, what's my first number? 0. Hey. Then what? 1. Awesome. Now what? Don't you say 2, that's not available. I already got 0. That's 11. Is there something before that? Okay, look, if I'm counting 0, 1, I can't use 2, I can't use 3, I can't use 4, I can't 5, 6, 7, 8, none of those possible. 9, not okay. Can I use 10 with only 1 and 0? Look, 1, 0. This just holds 2 spots instead of just 1. Right? What's the next number?
1, 1.
Yeah, 11. Yeah, 1, 1. If I'm counting, what's the next number that I can write with only 0s and 1s? 100. Then? 101? 110? 1,010, yeah? We can stop. That's probably pretty good, right?
And then you just keep on
1,100. We'll do that one too. Alright. So, this is binary. And the world we live in is the decimal world. So we live in the decimal world. That's how you learn to count. We have 10 symbols instead of just 2. Probably because people looked down and saw their fingers and said, there I have 10 fingers. Most of them did. Unless they got eaten by a bear or something. So they started counting in groups of 10. So they'd go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Any problems with that so far? It's pretty easy, right? Okay. Now, if I want to know what 1100 is, I can look at my table. And what is 1100? 12. But is there an easier way? Is there a way that I could figure it out without always having to look at the table? Okay, let's try addition. What if I add 1,000 plus 100? What would I get? Okay. So, what is 1,000 on the table? Y'all go with that? Right there? And then the 100 is just a 4? And you get 12. Y'all see what I'm doing? Should I try another one? Yeah? Yeah, you thought it was all weird technology magic and stuff. Not. Makes sense. So let's try this one. So let's say I have 1,110. What would be the things that you want to add together for 1,110? So if I wanted to add 1,110 up, I would do 1,110. Right? And so 1,000 is 8, and 100 is 4, and what's the 10 going to be? It's a 2. So that number must be 14. Right? Hold on. And actually, if you look, each one of these numbers just corresponded to a spot in the line. Would you all agree with that? Like this one corresponded with this 1,000. And this one corresponded with this 100. And this one corresponded with the 10. Yes? So, I could just make a fill in the blank. And I could say that if I see a number in the 4th spot, that's 8. And if I see a number in this spot, that's 4. And this one is 2, and this one is 1. So when my number is 1110, then all I gotta do is add up 8, 4, and 2. Y'all following? Because there's no 0. Or there's no 1 there. You know? So we could try it. 8, 4, 2, 1. And let's try 1001, which I know on my table should be 9. So I'm going to prove it to make sure it works. Right? This should be 9. So I circle what has a 1 on it, and I add those two numbers up. Now the interesting piece is like, let's say I have 7 blanks. And so I start with 1, and then I go to 2, 4, and 8. And all I'm doing is multiplying by 2. So what's 8 times 2? And what's 16 times 2? And what's 32 times 2? $128. You won't have to go any harder than that today. Huh? Do y'all have paper? High as you need to. And so let's make a number. Give me a number. Less than 100. 21. So if I wanted to do 21, I can't use the 128, I can't use the 64, I can't use the 32, I'll use the 16. 21 minus 16 is 5, so I got 5 left I need to add. I can't use the 8, that's too big. The 4 will be useful. 5 minus 4 is 1. Can't use the 2, I just need 1, and I'll use the 1. And that adds up to 21. And so your binary would be 1, 0, 1, 0, 1. That's 21. Okay? So we talked about the number system. We talked about how to turn binary into our system. And we talked about turning our system into binary. All I got to do is do addition and multiplication with you and we're done. Y'all ready? You need practice. You want to practice? Are you ready? Ready? Good? Well, let's go then. Alright, let's do some addition. Y'all are going to love this addition. This is the best addition. 1, 0, 1, 0, 1 plus 1, 1, 0. Let's do another one there. Good. Alright, let's add it up. 1 plus 0. Look, this is just like addition here. 1. 1 plus 0 is 1, right? What is 0 plus 1? 1. What is 1 plus 1? Can't write it. It's not 0, it's 2. 2 is 10, 3 is 11. Put the 0, carry the 1, just like you did in elementary school. What's 1 plus 1? Put the 0, carry the 1. 1 plus 1, put the 0, carry the 1. We added. Go us. Y'all need another example of addition? Are you ready to multiply? Can I multiply now? Yeah? 1, 1, 0, 1, 0 times 101. Y'all, this is great. You're going to think this is the best thing ever. 1 times 0. 0. 1 times 1. 1 times 1. 1. Now, if you're in grid paper, it's fantastic because all your little things just take one box and everything stays in a nice little line. Bro. 1 times 0 is 0. 1 times 1 is 1. 1 times 0. 0. 1 times 1. 1 times 1. Now in elementary school you might have learned to put a 0 on your next line, right? Is that correct? Yeah. You can do that if you want. I like to put a dash. It means the same thing. We're still doing the same process from elementary school. Now, 0 times 0. Okay, 0 times 1 is 0. 0 times 0 is 0. 0 times 1 is 0. 0 times 1 is 0. Easy line. And then, what did you always do? Now you would put 2 spots, right? And you can see why I may not want to put my zeros there because it gets messy. But putting a dash makes it easier to keep track of. And if you remember, when you multiply by 1, you just write the number again, right? So 1 times 0 is 0. 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1. And now, I just add them up. Zeros, 1s, 0. I did it. I multiplied. So that's all we're doing today. That's easy, right? Okay. So there's a quiz in Schoology where they have you turn numbers into binary and back and forth. And I want you to knock that out. After that, I posted this problem. Here, I'll put it on the stream or the video. So we have the binary quiz. It's in Schoology. And then there's practice problems. So I only want you to do 2 of each. So I'm not going to be like that crazy math teacher that gives you 40 problems. Right? I just want you to do 2 of each. And if you want me to, before you leave, you can show me and I'll just check it off in the rubric for you. And that way you don't even have to take a picture or anything like that. You're face to face. Just show me your stuff and I'll give you credit for it. It's actually due Friday, so you have until next week if you don't get it done today. So I want you to do 8 tasks, convert 78 and 90 to binary.